So let's talk a little bit about falls. So we know that falls are a significant health risk. For Canadian seniors, 20 to 30% will fall each year. And up to about 50% of older adults have had a fall. So the rates of falls are increasing year after year. And there's a larger percentage of falls in women than in men. Falls have a really significant outcome in that they are a major health risk, and they're the leading cause of hospitalizations for older adults over the age of 65. So as you know, this is a major problem and concern. Now, fear of falling is also a problem. And why we study fear of falling is that in older adults, greater than 50% report having a fear of falling, even though they have never fallen before. And in those that have fallen, 50% of those that have fallen before have a fear of falling. And about 30% of those that have never fallen before also report having a fear of falling. So it's a really large percentage of individuals that have some level of fear about falling. And the occurrence of reports of fear of falling is even greater in populations that have other issues. So individuals that have an inner ear disorder or a vestibular problem, in individuals that have Parkinson's disease, and individuals that have suffered from a stroke. So those types of groups have fear of falling that's an even higher level than others that are healthy. Now we know that there are significant impacts of that fear of falling as well. So fear of falling in older adults has been associated with a decrease in your balance confidence. It eventually can lead to restricted activity, like avoiding activities that you're afraid might cause a fall. That tends to lead to social isolation and depression in some individuals. And overall fear of falling is related to a decreased quality of life. So it's a major social issue. It also has an impact on your actual balance control. So if you have a fear of falling, you typically will have poor balance control. That seems intuitive. What's also surprising though is that it increases your risk of future falls. So if you have a fear of falling, you're 50% more likely to fall in the future than someone that's not reporting a fear of falling. So there's a relationship between how fearful you are and your likelihood of having a future fall. So this seems like an important problem to solve. There's some different studies that have been done to try to understand why balance and falls might be related to fear of falling and to what degree. And so a group of studies can be lumped together as those that take groups of individuals that report that they are fearful and compare their balance to the groups that say they're not fearful. And across all these different studies, the net result is that there are decreases in balance in the group that reports being fearful compared to the groups that report not being fearful. So there's some relationship there. Now there's some limitations to that kind of research though, because we don't know what is the cause of the relationship. So is the group that is fearful already having balance problems, and that's why they are in the fearful group, as opposed to are they fearful and then develop balance problems because of that. So this research is important, but it doesn't tell us what's the cause, what's the chicken and what's the egg. So we need to better understand this relationship between fear of falling and falls. Now the typical theory around how falls might be related to fear of falling and future falls is this idea of a vicious circle. And so the thoughts are that an individual has a balance problem or has had a fall in the past, and then that leads to a fear of future falling. If you become fearful, you might start to avoid activities. If you avoid activities, you decrease your physical activity and your mobility. And so this is going to lead to some type of physical deterioration over time as you stop going out and being active. That leads to decreases in balance control, and that leads to a future fall. So there's this vicious circle. But some of us are thinking that it may not be this direct relationship. There may be, this indirect relationship, but there might be a more direct relationship where fear of falling causes balance problems. And so what we're trying to understand is there a direct route between these two features? So in my lab, what we try to do then is take individuals and make them fearful and try to see how their balance changes. And so that might seem like a really weird concept, but I think I can give you an analogy that everybody can understand. So why would there maybe be a chance that if you're fearful, you may influence your balance behavior and performance? Well, if I take a beam and I put it on the ground, and I ask people to walk across that beam, even unhealthy university students, some of which are in the crowd, then most people will be able to do that pretty well while it's on the ground. Now, if I take the same beam and I raise it in the air, 10, 15 feet in the air, and I ask you to do the same task, everybody falls off. The task is exactly the same. The only thing that's changed is the consequence of the failure, or the fear that you develop about falling in that circumstance. So we know then that if we go from a safe environment where there's no fear to maybe a crazy environment where you're fearful, it will influence your balance performance in some way. And so if that's what happens when you're walking on a beam, we can maybe assume that the same thing happens when you're just even standing and balancing under fearful conditions. And so we use this paradigm to look at fear and its influence on balance. So in our lab, what we use mostly is a hydraulic lift that can be down on the ground level and have individuals stand on this platform. So you're in a low, safe environment. There's low threat in that circumstance. And then we can raise the lift up to different heights and increase individuals' anxiety or fear about standing in that circumstance and see directly in that individual how their balance changes. And if we take healthy individuals and we understand what components of balance might be sensitive to fear and anxiety, we might be able to relate that to individuals that have fear under normal circumstances. So we started off with experiments using this fairly small hydraulic lift. This takes you to about the height of standing on your dinner table to about my height, so 1.6 meters in the air. And then when I came to UBC, we had a bigger lab, so I got a bigger platform. And so now we can raise people to about 3.2 meters in the air, so about 20 feet in the air. And so we can grade the level of anxiety and fear that individuals have and see how their balance changes. We also use virtual reality as a way of putting people in fearful situations. So you can wear, for example, a head-mounted display, and we could put you in a virtual environment where you may be standing on the top of the CN Tower, or you might be standing in the middle of an icy surface, or places where an individual might have an increase in anxiety or fear, and then see how does their balance change in that particular environment or context. Just quickly, some of the measures that we take to assess how our manipulation is influencing people's emotion. We can look at different types of factors. And so a lot of these are used interchangeably, so I thought I would just really briefly touch on them. And so we typically use questionnaires to ask people to self-rate under different circumstances how they feel. One of the measures we take is a measure of their fear of falling under that circumstance. And fear is a very specific emotional response. It is a physiological response to an actual threat or a perceived threat. So you think about the fight or flight response that you have when you're fearful. So we're trying to assess, does somebody have this very physical reaction to being in a particular circumstance? Now, anxiety is a little bit different. It's an unpleasant state of uneasiness or concern, and the threat is not immediate. It's something which is a little more non-specific. So you can be anxious about something, and it's not a tiger roaring right at you. It's something in the future, or something you're thinking about, or it's just a little bit more abstract. And anxiety has a physical component to it. You can feel when you're anxious. Your palms might be sweaty, your heart might be racing. But anxiety also has a cognitive component to it. You start to worry or sort of ruminate about what might happen. So that's very specific to anxiety. Now, confidence is another measure, and confidence, sometimes called efficacy, is really a perceived ability to do a task in the future. So we assess your confidence before you do something. How confident are you that you can stand in this circumstance, that you won't fall off the platform, for example? And so it's based on your previous experience and how you rate your own ability at that time. Finally, arousal is another measure. It is a direct measure of how your body is responding to a certain circumstance. So we measure it in our lab usually using skin conductance, so how sweaty your palms are, like a lie detector test. Other measures of arousal could be increases in your heart rate or increases in your blood pressure, and they all indicate that your nervous system is getting excited or aroused. And arousal can be a positive response and it can be a negative response. So there's those different types of measures that we use to really confirm that what we're doing in the lab is having an effect. And so this is a sort of two views of standing in our lab under the low circumstance. So when the platform is very low on the ground, you see they're sort of at the level of the computers there. And then on the bottom right is a view from standing at the top of our platform, so about 20 feet in the air, looking down on the student working on the computers. Now that's the real picture of standing under that circumstance. But what's interesting is in the virtual environment, we can recreate those same types of perceptions. So on the left, you can see how we've created the lab in the computer virtual space. So you could be standing in here in this lecture hall and have the sense that you're standing high up on the tower or down on the ground. So we know that both types of scenarios will have the emotional effect that we're looking for. So whether you're standing on a real high platform or you're in the virtual world and standing on a virtual platform, we know that your perceived level of anxiety increases significantly. People's response about how fearful they are also increases. Their confidence about standing under that circumstance decreases, and their physiological arousal increases. So we know that the paradigm has an effect. But the big question is, how does your balance change when you're now put under these fearful circumstances? Now, most of our studies are done in young university students, but we have done some experiments also in older adults and different patient groups. The reason we do a lot of the work in young university students is we want to be sure there's no underlying balance problem, and then can we take these healthy students, make them fearful, and see if their balance changes. So there's different ways of measuring balance in the lab, and the first one is to use really functional measures of balance. So these would be very simple tasks that you may be asked to do in a clinic to assess your overall balance capability. So for example, you may be asked to stand on one leg and see how long you can stand on that leg before having to take a step. You sometimes are asked to do a functional reach, where we have you stand up against a wall and lean as far forward as you can without losing your balance and taking a step. So more about your stability limits, if you will. And other measures ask you to do more dynamic tasks, like rise up onto your toes and then maintain that position in a balanced state. So if we take those tasks and we see how do they change when we make an individual fearful, are functional balance tasks sensitive to this fear? And what's interesting is across the board there are changes in even healthy young people's balance when they are fearful. So their one-legged stance time decreases about 12%. The amount of reach or lean that they'll do when they're fearful decreases about 10%. And if we look at the level of failure rates, so they're rising up on their toes and the number of times they just can't do it and they fall down or they overshoot, it increases from about 2% to 20% when they're fearful. So we know that these simple clinical tests of balance are sensitive to underlying levels of fear and anxiety. That's important to know. But clinical measures are very broad, they're subjective, and we really want to know what's happening within the balance mechanisms themselves. So we want to take a more objective measure of balance control, and that as a whole is called posturography. So objective measures of balance, either quiet standing or under more dynamic standing tasks. So to give you an example of this static versus dynamic balance, static balance is measured while an individual is standing in one place, trying to stand as still as possible. And even if you're trying to stand as still as possible, we know that there is a certain amount of sway that you will have forwards and backwards and side to side. Now, it's not as drastic as this happy fellow up here, but just to give you a sense that even if I had you stand up and just close your eyes and stand as still as possible, you would feel yourself constantly swaying back and forth and side to side. Okay? So that continuous sway is controlled by your nervous system to make sure that it doesn't get too large and you fall over. And so we can use measures to figure out how much sway you are having during that stance. Now, the other types of tasks are dynamic balance tasks. And those types of tasks really look at how your nervous system responds to a sudden balance disturbance or a fall. So how do you correct yourself from falling over? So I'm going to talk a little bit about the different ways that we measure these types of balance control, and then we'll look at some of the influences that fear has on these different elements of balance. So the static posturography is simply a way of measuring how much sway you have when you're standing still. And the way that we do that usually is by using what's called a force plate. And a force plate is really a fancy weigh scale that you stand on. That force plate has transducers in there that measure the forces or the pressure underneath your feet. And it can calculate a central point, for example, to represent how the center of your body or your center of mass might be moving back and forth and side to side during that standing task. So here in the middle, if you see the two footprints, you can imagine looking down on the force plate from above, and the red line is really how that center of mass of the individual is moving over time. And that's being measured by the forces under the feet. And then we can graph that movement over a period of time. So on the top right graph is, imagine again, looking down on the body and the force plate and seeing how the person is swaying over, let's say, 60 seconds. And you can see there's a certain amount of sway forwards and backwards and side to side. So we call that a spaghetti plot because it looks like a bunch of spaghetti on your plate. But we can also, and we can measure how large is that sway over that 60 seconds. You can also take that overall sway and break it down into different directions. So we can figure out how much of that movement of your body during standing was in the forward and backward direction, and how much of it was in the side to side or the medial-lateral direction. And so that's what we show on the bottom right, is we've taken the same graph from above and we've broken it apart into the forward-backward components and the side-to-side components. Okay? And then we can do measures on that. We can figure out, well, how much amplitude of movement was there? So how much sway was there in that direction? Or how fast was the movement changing, or the frequency of the change? Okay. So when we look then at those types of measures under fearful circumstances, we see that the way an individual controls their balance, even when they're standing perfectly still, changes when they're fearful. So in the graph, the gray lines represent that sway over 60 seconds of a young individual standing on the ground. And the red shows them when they're way up high on the platform. So you can see that the amount of sway that they have gets smaller in size. And if we sort of measure that, we can see that there's a significant decrease in the amount of sway that they allow themselves to do when they're fearful. Now, at the same time, we can look at the speed or the frequency of that sway, and the opposite happens. So they sway in a smaller range, but the amount of changes or the speed of that movement increases. And if you think about yourself being controlled like a pendulum, then a smaller movement with faster changes or speed means that the whole system is stiffer. And so we see this pattern of individuals becoming stiff when they are fearful. Your balance becomes controlled in a more stiffer way. Now that's in young individuals, and there's been some studies in older adults to show exactly the same thing happens. So this was a study by a group in Australia. They had older adults standing on the ground and then standing on a box that was only 60 centimeters in the air, so probably no higher than this table or on one of your chairs. And it might be hard to, so easy to see. So what they found was the same type of behavior in older adults, that comparing their amount of sway, the amplitude, on the floor, which is on the left part of that graph, to when they were standing on the box, the amount of sway decreased. And that was in the group that felt that they were fairly confident in the way that they could balance. What they did find, though, was that if you take another group of older adults that reported before the experiment that they were very anxious about balancing, then their behavior in the same two conditions was very different. They didn't do that corrective change of making their sway smaller when they were at height. They actually swayed just the same amount. So there is some variation in people's response based on how they are fearful to begin with, and then when they're put in these different conditions. We also see differences in older adults' response to fearful scenarios using a different context. So this was another study by a group in Ontario, and what they were doing is using not the threat of standing on a platform to look at anxiety and fear, but the threat of being pushed. So they had someone standing behind the subject, and every once in a while they gave them a little nudge in one direction or the other. Not enough to push them over, but enough to make them have to respond. And having that person behind them ready to give them a push is enough to increase people's anxiety and fear. What they found is in the young group, when they were standing with that threat of being pushed, they changed their sway in a way which let them be more movement when they expected being pushed. And that makes sense. If you relax and you're going to get pushed in the trunk, you can take and absorb that force more easily than if you are stiff. Fortunately, in the older group, we found that when they were under the threat of being pushed, they decreased their amount of sway. They did stiffen up under that circumstance, which means that the push is going to have a greater effect. So we see different strategies in young and older adults on how they manage these threatening scenarios. Now there's some questions about whether the behavior that we see when you're standing on a high tower or when you've got some experimenter behind you ready to give you a push is really the same as the kinds of anxiety that you might experience in everyday life. And so to be sure about that, we've tried to use some different ways of increasing people's anxiety and arousal in the lab. And one of them is to use social anxiety. So social anxiety, it occurs when you're motivated to make a desired impression on others, but you're not certain about if you're going to be able to do so. Or put in another way, your social anxiety increases when you're performing in front of an expert or some authority that you're trying to impress, and you think that there might be a negative consequence if you don't do well. So the perfect example for this in the balance scenario would be having to do balance tasks in front of your clinician, especially if your clinician may be taking the way you balance and making determinations on what you can do part of your active life, whether that means you may have to go into a different living arrangement, etc. So we know there are white coat effects even on people's blood pressure when you go to the doctor. Your blood pressure goes up just by the fact the doctor is taking your blood pressure. And so for the same sake, we wonder, does your balance change when you're performing in front of a person in a white coat than if you were performing under a different scenario? Another example would be if you come into my lab and we set you up with all this equipment and we say, okay, behave normally. And so we know that the state in which you're having to perform might change your anxiety and your fear. And the question is, does that then impact your performance? So we did a really simple study. We took two groups of female subjects. One group were young, healthy undergraduate students. The other was the older, healthy females that were from the community. And we had them come into my lab, and we had a number of different balanced tasks that they performed under two conditions. So the one condition, there was a person in a white coat standing in the corner, and they were told that this person was assessing their balance and was going to be scoring how well they did. In the other condition, there was no doctor or white coat in the room. So that's the only manipulation we made, was the presence of an evaluator or a doctor in the room. So we wanted to know, how does this affect people's anxiety and their fear, and how does it affect their balance? What was really interesting was, in both the young females and older females, the presence of the evaluator significantly increased their anxiety, and it significantly increased their fear about doing that task. So we know that it had an effect on both groups. The question is how it influenced their balance. So what we found was that the balance changes were specific to the older group. The young group didn't change their balance, but the older women in our study, their one-legged stance tasks, for example, were significantly shorter when they performed it in front of the evaluator than when they were alone. So just the presence of the doctor made their performance decrease. If we look at that quiet standing task and the amount of changes in the sway behavior or the speed of that behavior, remember that it was higher when we stood up high on a platform, and we saw the same behavior in older adults performing in front of a doctor, that they started to stiffen their balance and have this much faster variations in their sway. So stiffer balance control only because of the anxiety of performing in front of somebody else. We've taken those experiments even further and said, okay, what about if we don't affect anxiety or fear, we just increase your arousal a little bit? And so one of the ways that we can manipulate arousal is to show individuals pictures that have been rated to have a different effect on your emotion. So some pictures are known to cause an increase in your arousal when you view them. Others cause you to have a decrease in your arousal. And there's another aspect to them too, where some pictures are pleasant and arousing, and some are unpleasant and arousing. So we wanted to know, what is the key feature that changes your balance under emotional changes? Is it the unpleasantness of being in front of a doctor or on a platform? Or is it the fact that your nervous system is just activated and aroused? So we did a really interesting study where we just had people standing on a force plate, doing different balance tasks, and they were looking at pictures that were known to have different effects on your emotion. So I'll give you some examples. So on the top left, this would be a picture that is a nice positive feeling and a low arousal, little stuff in. A negative feeling is, for example, a picture here of a graveyard, but it doesn't have a strong arousing response to that. In contrast, pictures of sort of extreme sporting events or anything with sort of some erotica component to it, of course, is high arousing and considered to be positive. And then we may have high arousing and negative feeling pictures too. So we showed them these series of pictures simply while they're standing on the force plate. And what was interesting was, as we'd expect, the low arousing pictures decreased their arousal, and their high arousing pictures increased their arousal. But when we looked at their balance control, it had an effect as well. So just by changing someone's underlying arousal, whether it's positive or negative, their balance started to change in the same way that we saw when they were standing high up on a platform. So those were changes in sort of static balance control. We've done some studies also looking at more dynamic balance. As I mentioned, dynamic balance is looking at the way that person reacts to a expected or an unexpected disturbance. So I'll give you an example here. Now this this might be something that may be unexpected or may should have been expected. Not a lot of hope of maintaining balance in that scenario, I'm pretty sure at this stage. So, but that's just a funny example. But more realistically though, you can think about lots of scenarios in real life where your balance is unexpectedly or expectedly perturbed. So good examples would be when the floor moves underneath your feet when you're standing on a train or a sky train. And those would be translations of the floor that suddenly move, like someone's pulling a rug from underneath your feet. Or you can imagine that the support surface might rotate under your feet, similar to standing on a moving boat or on a dock. So we can try to recreate those kinds of perturbations to your balance in the lab. And so we have these moving platforms that you stand on, and they will slowly or suddenly move in a translation way under your feet, similar to the way that a subway would move. Or, as shown on the right, we have other platforms that suddenly tip in different directions. And so these will cause you to have to generate a balance response. It's not enough to cause you to fall over, but it causes your nervous system to generate a reaction. And we can look at how that reaction is unfolding. There's different ways we can measure that balance. We can, again, use force plates to see how you generate forces under your feet. We can look at your strategy of maintaining balance. So we use markers that we can put on different parts of your body that special cameras can see in real time and in 3 dimensions. And we can recreate then how your body moved under that different circumstance. So did you raise your arms to grab a rail? Did you balance more with your upper body? Did you take a step? So we can characterize your body movements. And this is very similar to the CGI that they're using in a lot of the new movies. We can also measure your muscle activity. So we can put electrodes on the skin and measure what muscles are being activated when you are recovering from a fall. Are you using more of your legs? Are you using the muscles of your trunk? Are they coming on at the right time and in the right pattern? So those are just some of the tools that we use. We've done a few studies to look at how dynamic balance responds to fear. And so there were some of my original studies in Waterloo. We had one of these rotating platforms strapped on top of the hydraulic lift, and we were raising people to different heights and then pushing them over. Not off the platform, but just enough to cause them to do a balance response. More recently, we've done similar types of experiments on translating platforms using virtual reality. So you'll be standing on a platform that might be moving, and you'll be perceiving that you're either in an environment where you're down low on the ground, or we can, with the virtual reality, raise you high in the air like you're standing on one of those cherry pickers, and then have the floor move underneath your feet. So we can look at your balance response under these fearful conditions. Briefly, what we tend to find when people are fearful and responding to balance perturbations is that the muscle responses that they initiate are much larger in amplitude than you would find when they're not fearful. And those muscles that are activated are not just the ones that are responsible for that particular perturbation, they're more general. So all the muscles go off, and they all are activated at a much higher extent than would be when you're not fearful. The muscles also tend to come on much earlier in time. And so when they're coordinated together, what happens is that the response becomes much more of a stiff, general response, and not appropriate for the particular direction of fall that we're causing. So to give you an example, on the top right graph, if I was tilting the platform to the left, the right response for somebody who wasn't fearful is to really allow the lower legs to go with the platform and move the upper body in the opposite direction, so to counteract the movement of the ground. You can imagine if you have a balance response which is fearful, where all the muscles are activating and you're stiffening up your whole body, then the whole body will fall like a log in the direction of the platform movement. So there are responses that we're seeing in fearful individuals that might be maladaptive or might be causing the fall. So just to summarize then some of the observations we've made so far, we know that fear and related emotional factors can have a significant influence on balance control and walking behavior and even other movements. We're not really sure about what are the underlying mechanisms that cause someone who's fearful to change their balance control. There are some ideas, and we have some evidence from things in the lab so far. One of the ideas is that the sensory systems that you have to control your balance, so the receptors in your inner ear that detect where you are in space, the receptors in your muscles that know when they're lengthening or shortening, and even your visual system that tells you how you are balancing. We have evidence to show that all those sensory systems are tuned up when you're fearful. They just have more information coming in than what's under normal circumstances. And so that might cause your nervous system to generate responses that are overactive or excessive. So there might be just a whole volume of the nervous system that goes up when we're fearful. The other theory is that when we're fearful, our attention, or the focus of our attention, changes. And there's two thoughts on this. The one is that some elements of balance are really automatic. When I'm standing here talking to you, I'm not thinking about my balance. I'm not focusing all the time to make sure, oh, I'm swaying this way, oh, I'm swaying this way, don't fall over. It's really dealt with in a much more automatic way. When people are fearful, what we find is they turn their attention inwards. I don't want to fall, so I better start thinking about my falling. I'm going to focus on my balance. I'm going to focus on what I'm doing all times, generate strategies that I think might make me more balanced. But in fact, I'm now taking conscious control over something which is usually controlled automatically. And that may mean that the behavior will change and be less effective. Finally, we're seeing that there are changes in people's perception. So even how you perceive your swaying changes when you're fearful. We find when people go high up on the platform, remember their sway amplitude or size of their movements goes down, it gets smaller. But when people are standing on the platform, they report that they're swaying more. They always come down and say, oh, I was swaying all over up there. I couldn't control my balance. And yet they were actually swaying less. So the way that the brain perceives your balance control changes when it's in a fearful or anxious state. So lots of things contributing to that. And so it might have also really important clinical implications and even implications for the way we study balance. So one example is the idea of a first trial effect. We know that when someone comes into a new situation, for example, coming into a lab or coming into a clinic, their arousal goes up. And then over time, that arousal decreases. And so we were wondering, well, if you just come into the lab and you perform the same balance test once, and then we give you a few minutes and get you comfortable with the lab and you know what's going on now, and you do the same test again, is there any difference between those two scenarios? And in fact, we see a significant change in balance the very first time you do the experiment, when you're uncertain of what's happening and you're a little anxious. You can see that the sway amplitude in blue is decreased compared to the second time you perform it, and the speed or the frequency increases. So the same behavior that we see standing on a tower, we can identify between your balance tasks from the first time you do it, and you might be a little anxious, to the second time. So that has implications for being tested for interventions of some type of a treatment, knowing that the first time might be influenced by anxiety. It also means when we're comparing between groups, where one group might have a fear and another group may not have a fear, that might be playing a role in the differences. The other thing to keep in mind is more from a clinical point of view, that what presents itself as a balance problem that might be physiological, there may be some psychological or emotional elements to it. We know that the fear of falling can have some influence on balance. And so just as a good example, if I showed somebody this picture of this girl, they may look at her and say, wow, her balance is really strange. There must be something physiologically wrong with her balance control. And yet what we don't know is what her emotional state is, what her perception of that context is. And so if we knew that she was perceiving this environment, then her balance behavior might be quite normal for that circumstance. So just as a caveat when we're trying to look at clinical interventions, to know what is the physiological causes of balance problems and what are some of the emotional and psychological factors. That has real implications for things like treatments, because there's a need now to look for treatments for balance problems that not only address perhaps some of the physiological factors that contribute to them, but also address the things like fear and anxiety and confidence that we know can influence your balance. So there are some studies that are looking at whether things like physical activity, exercise, things like hip protectors, and things like behavioral therapy that look at some of the psychological factors may also have an impact on your balance control because they treat those fear and anxiety components as much as other aspects of balance. There's been a couple studies that have tried to look at this. And this was more around whether we can use interventions to reduce fear of falling in older adults. So there was a study by Zielstra et al., 2009, and they did a review of all the studies in the literature which were trying to use some type of intervention to reduce fear of falling in older adults. There was a widespread number of studies that they first looked at, but when they boiled it all down, there were only 12 studies they found that were considered high-quality studies that they could interpret the results from. And of those 12 trials that used some kind of intervention to change fear of falling, they found that 11 of the 12 had a significant effect of improving individuals' fear. When you looked at the different interventions that were successful, they included home-based exercise programs. So 2 of the 11 studies used home-based exercise, and that was significant to reduce fear of falling in those individuals. 3 studies found that some type of community-based Tai Chi exercise was very effective at reducing fear of falling. 5 of the studies used multifactorial balance training. So that means they combined physical balance training with some other behavioral components of trying to reduce fear as well, and they were effective. And the 1 study that used hip protectors, really as a means of reducing the impact of a fall, they found that just wearing the hip protectors increased people's confidence and decreased their fear of falling. So lots of evidence that there are different ways we can use interventions to reduce your fear of falling, and I think that's important. There was another study that focused just on different exercise programs, and they found that there were 30 studies, including 36 different exercise programs, that tried to reduce fear of falling in community older adults. 19 of them used some form of balance training. 8 of them used strength and resistance type exercise, and 9 of them used Tai Chi as an exercise component. When they looked at the effect of all of those different studies, they found there was significant evidence that there was a small to moderate improvement in fear of falling using some type of these exercise programs. And those improvements were found to last at least up to 6 months after performing the intervention of exercise. What's unclear is how long after that those improvements will be maintained, but certainly immediately after and 6 months post, there were small to moderate improvements in fear. Just want to end with the idea that obviously it's important to understand that fear of falling has an influence on our balance, and there's ways of trying to do different types of training, exercise, or other interventions to reduce that fear. But the question is, to what extent? So, should you be fearful or should you be fearless? And I think probably the answer is somewhere in the middle. So our evidence definitely suggests that too much fear is a bad thing. If you're fearful, then you will change your balance control. You may assume behaviors that may be maladaptive or causing you to potentially fall in the future. And they have the unwanted consequence of causing you to avoid activities that may otherwise promote your balance control. On the other hand, being fearless maybe isn't wise either. So there's this interesting article in the paper of a gentleman who was trying to keep a bull from charging his car, so he jumped out and faced it with his hat. And so this kind of fearlessness maybe isn't wise either when we're talking about our balance. No fear is probably not a good thing because you may overestimate your capacity. And there are scenarios where you might not then use protective strategies that are otherwise helpful. So the thought is that you should be cautious, that you should respect the conditions and the context you're standing, but over excessive fear falling is not helpful. Just like to end there by acknowledging all of the different collaborators that I do research with at UBC and different universities. There's a large number of graduate students and undergraduate students that are involved in research in my lab, and a number of different funding sources that support the research that we do, including NSERC, the CIHR, and Canadian Foundation for Innovation.